Hello, everyone. Good morning and welcome to our course, Electrostatics. I will be sharing my screen with you for our first module discussion. Okay, so let me remind you that this lecture recording is our TBOA, and you can still see me for consultation hour every what was our schedule for our consultation hours? Every Thursday at 10 a.m. to 11 a.m. All right. So during our class schedule, the TOA schedule, we are not going to meet. So that means you have the flexibility on when you are going to watch this lecture recording and when you are going to work on your module. But I hope that you will be working on your module before Thursday of every week so that by Thursday during our consultation hour, you will be asking me some questions, clarifications with regards to the topic. Okay, so I will be addressing to your questions during consultation hour. Okay, so even though you will not show up during consultation hour, but I will still be here on our Google Meet. Okay, so let us now proceed to our discussion. Can you see my screen? Yeah, of course you have to see my screen. Sorry. Wait for a while. I will check if my screen is there already. What is happening? Okay. Yeah, it's there. All right. Okay, so welcome to our course again, electrostatics. So what is electrostatics? Okay, so it comes from the two words electricity or electric rather, electric and statics. So when we say electric, this refers to, or this was derived from the Greek word electron, which means ampere. Okay, so when you say statics, those are for objects that are not yet in motion. Okay, so for this time, it is not yet. We will not be talking about electricity yet, because electricity, that means the electrons are already moving. But this time, it is electrostatics, meaning there is no motion yet. Okay, so there is no current flowing yet. Okay, so we will be starting electromagnetism with this topic. Okay, so first and foremost, let's have electric charge. Okay, so there is the law of conservation of charge, which states that the net charge of a closed system never changes. So that means whatever charge that enters the closed system will be equal to the amount of charge that will get out from the system. So it is just like basically the law of conservation of mass or the law of conservation of energy. Okay, so the fundamental charge that one electron has is 1.6 times 10 to the negative 19 coulomb. Coulomb is the unit of charge, okay? Of course, that comes from the scientist Charles Coulomb, and it is being represented by the capital letter C. So kindly take note of your units again, guys. Okay, so there are two types of charges, the positive and of course the negative. For a positive charge, there is a shortage of electrons. And for the negative charge, there is an excess of electrons. So, for the law of conservation of charge, again, the net charge of a closed system remains constant. So, the net charge would be, uh, there will be equal positive charges and negative charges. So if you are going to have the sum of that, that would be equal to zero. All right. So as what you may recall in your chemistry, you have your atom, and at the center of the atom is the nucleus. The nucleus are we have our subatomic particles in the nucleus. The positively charged protons and the neutral neutrons, while outside the nucleus are the negatively charged electrons. Okay, so with that, an object will be positively charged if there is lack of electrons in it. But if there will be an excess of electrons, that's the time that an object will be negatively charged. Okay, so if the number of electrons is less than the number of protons, then you have 3.2 times 10 to the negative 19 coulombs. Okay, and if your number of electrons is greater than the number of protons, then you have negative 3.2 times 10 to the negative 19 coulombs. But for neutral atoms, the number of electrons is equal to the number of protons. Now, how are we going to charge such objects? Okay, so there are three types of charging. First is the friction or rubbing. When you are going to rub one object with the other, charge will be it will be charged. One will be positively charged and the other will be negatively charged. Now, second is the charging by conduction. For charging by conduction, there is direct contact with the object. So say for example, you have a metal sphere and you have an ebonite rod. You charge the ebonite rod, so while charging the ebonite rod, it is negatively charged. And if you touch the neutral sphere, metal sphere, so the negative charge of the ebonite rod will go there. The electrons will go. So the metal sphere will become negatively charged also. Now, next is, sorry guys, this is conduction and this is induction. Okay, so the third one is induction. Okay, so for induction, there will be no direct contact between the objects. Okay, so say for example, you have your metal sphere. This metal sphere is neutral, and you have your ebonite rod, which is negatively charged. And then you just put it near the metal sphere. There is no direct contact. Okay, if you take a look at that, the two objects are not touching each other. While in conduction, the two objects are touching each other. Okay, so here the metal sphere will polarize. When we say polarize, one end will be positively charged and the other end will be negatively charged. Okay, so since the ebonite rod is negative, so the positive will be attracted to it. Okay, because opposite charges attract. So that's the time, okay, when you put the negatively charged object near the metal sphere, it will polarize. Then the negative charge will be grounded, okay, and that is a grounding wire that is connected to the ground. So the negative will go there to the ground and the metal sphere will become positively charged. Okay, so that is charging by induction. Now, how are we going to know that if we are going to charge an object through friction or rubbing, it will become positively or negatively charged? Okay, with that, we have our triboelectric series. For the triboelectric series, we have our table for that, okay, wherein the objects or the materials are being arranged. Okay, so say for example, we have celluloid, sulfur, silk, cloth, fur, wool, and glass. This materials are being arranged according to the triboelectric or the affinity of the electrons. All right. So for here, as our materials going up, it becomes negative. And as it is going down, it becomes positive. Okay, so you have the references in your module, so you may take a look at the other materials in your references. So again, going up in this series, it becomes negative because of the electron affinity, and going down from the series, it becomes positive. So say for example, you are going to rub silk and glass together. Okay, so you have a silk, you have a glass, you rub them together. Which one will be negatively charged and which one will be positively charged? So let us take a look at our triboelectric series. Silk is here, okay, while glass is here. So as what we had said earlier in this series, going up, going negative, going down, going positive. So silk therefore will be negatively charged while glass will be positively charged. Now in your laboratory for module 1, you are going to rub objects together, okay? So say for example, we have our ball pen, okay? And we have our hair, okay? You are going to rub your ball pen in your hair. I know you're doing this in your elementary. And then you're going to take a piece of paper, and once you rub your ball pen, the piece of paper will be attracted to your ball pen. Okay, why? Because you are charging. Okay, you are using your hair to charge the ball pen, and once your pen is charged, you are going to put a piece of paper and then it will be attracted. Okay, so now you can determine what will be the charge of the pen and what will be the charge of the paper through the triboelectric series. Okay, so that's what you're going to do in your laboratory. Not only pen, not only hair. Okay, so another example for that is when you comb your hair, what will happen? The comb will be electrically charged also. Okay, so there are more things that you're gonna do in your laboratory for module 1. Okay, you're gonna rub objects together that can just be found at home. Okay, so with that, since there is negative, there is positive charge, okay, so you create now an electric force. Okay, now there are two types of attraction. First is repulsion, and of course, second is the attraction. Like charges repel, while unlike charges attract. Okay, so you all know about that already. So no need to further discuss. So since we are talking about electric forces now, we can compute for the electric force by using Coulomb's law. Okay? Coulomb's law gives the electric force between 2 point charges. And it is being represented by the formula F is equal to K Q1 Q2 over R squared. Okay? You must take note here that Q1 and Q2 is in absolute value. Okay, so that means if it is negatively charged or positively charged, the force depends on the direction. There is also direction, but you are not taking the, say for example, one is negative and the other is positive, so directly that will be negative force. Okay, so that's not the issue there. Okay, so kindly review on your vectors. Okay, you had your vectors in your senior high school, so kindly review on vectors. Force is a vector quantity. All right, so here K is Coulomb's constant, and it has the value of 9.0 times 10 to the 9 Newton meter squared per Coulomb square. Okay, some sources say 8.99 times 10 to the 9. All right. So Q1 is to charge on mass 1, Q2 is to charge on mass 2, or object 1 or object 2, and R is the distance between the two charges. The electric force is much stronger than the gravitational force. We already learned what is gravitational force in your physics 1 or in your senior high. Okay, and gravitational force is having almost the same formula with the Coulomb's law. The Coulomb's law is taken from the gravitational force formula from Newton's universal gravitation, which is gravitational force is equal to G Capital letter G, the universal gravitation constant, times mass 1 times mass 2 over r squared, which is the distance between the two masses. Now let us have our example for that. Okay, by the way, I am also posting this slide for you guys. Okay, so everything is given for you. This lecture recording, this slide, okay, and it's up to you when you are going to watch, when you're going to read your module, but please do read, watch, and start more working on your module before Thursday of each week for our consultation hour. All right, so let's have his first example. Two charges are separated by a distance r and have a force F on each other. All right, so we have the two charges. We have Q1 and we have Q2, and they are separated by a distance r. Now, what must be the charges between Q1 and Q2? What must be the charges of Q1 and Q2? Is it positive for Q1 or negative for Q2, or positive both or negative both? Okay. So as what you can see here, these two objects, the electrical force for Q1 is going this direction and the electrical force for Q2 is going this direction. They are repelling each other. So Q1 and Q2 have the same charges, either both positive or either both negative. Okay. Now, using our Coulomb's law equation, if R is doubled, then F is 1/4 of F. Okay, because you are doubling the distance. So doubling the distance will decrease the electric force. Now, if Q1 is doubled, then F becomes doubled also. Okay, if we are going to increase our charge for Q1 or Q2, our electric force will also increase. Now, if Q1 and Q2 are doubled and R is halved, then the electric force will be 16 times the force. Okay, because you are doubling your Q1 and Q2 and you are decreasing the distance. So that means the greater the charges, the greater the electrical force. Okay? The greater the distance between the two charged objects, the lesser the electrical force. But the nearer they are, the greater the electrical force. All right. So let's have this example, our computation. Okay, there are two gram masses. Kindly take a screenshot of this problem because I will be sharing to you another screen for the computation so that while I am computing, you are taking glances of our problem. Okay, so let us read our problem first. Two 40-gram masses, each with a charge of 3 microcoulomb, are placed 50 centimeters apart. Compare the gravitational force between the two masses to the electric force between the two masses. All right, so let me share to you my notes. Let me know if it is there. Okay. Is it there? I'll check. Okay, it's there. All right. So we have our two charges. One is 3 microcoulomb and having 40 grams. Okay, what a big circle I have here. And another 3 microcoulomb with 40 grams. And they are 50 centimeters apart from each other. Now you are going to compare the gravitational force between the two masses and the electric force. Okay, so with that, I will not be giving you the computation for gravitational force because you have that again in your senior high. What I will be giving to you is the computation for the electric force. All right, so from Coulomb's law, the electric force, I will have it as F sub E, meaning that is an electric force, and F sub G will be the gravitational force. You compute for that. And that is equal to K Q1 Q2 over R squared. All right. Wherein K is the Coulomb's constant. I am using 9 times 10 to the 9 Newton meter squared per Coulomb squared. Okay. You can also use 8.99 times 10 to the 9. It's up to you. Now, Q1, I don't have space there anymore. So, wait for a while. Okay. Times Q1. Just multiply this one. Q1 is 3 microcoulomb. Okay? And Q2 is also 3 microcoulomb as in the given. So kindly take note, your Coulomb's constant is having the unit column. Alright? So you must have all units to be in column. So 3 microcoulomb, that will be equal to 3 times 10 to the negative 6 coulombs times 3 times 10 to the negative 6 coulombs. Okay? Over r squared. What will be r? R is the distance between them, which is, what was our distance? 50 centimeters. And our Newton's constant again is in meters, so you must have it in meter. So 50 divided by 100, that would be zero point 0.5 meter. So the column cancels out, and our meter cancels out. So what remains is Newton meter. Okay. Now, sorry, this is squared, okay, because it is r squared. So meter squared also cancels out. Now, what remains for our electric force? Of course, it is in Newton. Okay, and get your calculators, kindly compute, just multiply and then divide by zero point 0.5 squared. Never forget to square your zero point 0.5. So our answer would be 0.324 newtons. That is our electric force for our first problem. Okay, and again, for your gravitational force, kindly compute that for yourself and then just compare which will be greater or which will be lesser, the gravitational force or the electrical force. All right, now let's proceed to our next problem. For our next problem, this is a bit challenging for you guys because we are going to have angles this time. Okay, so I will be sharing my slide with you again. Resume presenting. All right. What is there on your screen this time? Okay. Is it the slide already? I'll check. All right. It's the slide already. Okay, so we have three charged objects that are placed as shown in the illustration. You're going to find the net force on the object with a charge of negative 4 microcoulomb. Okay, so you have your 5 microcoulomb charge, you have negative 5 microcoulomb charge, and you have negative 4 microcoulomb charge. This is negative here. Okay, so kindly take a screenshot or take a photo again so that later when I show you the solution, you can glance at the problem. All right. Now, the 5 microcoulomb charge and the negative 4 microcoulomb charge is 20 centimeters apart, as well as the 5 microcoulomb and the negative 5 microcoulomb charge. They are 20 centimeters apart. Okay. Now, they form a right triangle, right? Okay, so that means this is the hypotenuse. You can compute for the hypotenuse using the Pythagorean theorem. C squared is equal to A squared plus B squared. So the value for our hypotenuse here, 20 squared plus 20 squared, is 28 centimeters. So negative 5 microcoulomb and negative 4 microcoulomb is 28 centimeters apart. This time, it is very important to learn the direction of the electric force. Okay? This time, you are going to consider the attraction or the repulsion. Where is the force going? Okay? So here, you have negative 4 and positive 5. So that means positive and negative, they attract to each other. So our force one, F1, because they attract, it's going towards the direction of the positive 5 microcoulomb charge. Okay, is that understood? Now, on the other hand, you have a negative 5 microcoulomb charge and you have a negative 4 microcoulomb charge. So they have the same charges, like charges repel. So our F2 will be going in the opposite direction. All right? So again, F1 is going towards this charge because they attract, they have unlike charges, and F2 is going in this direction. They repel because they have like charges. Okay, so for here, you are going to get F1, so for F1, and you're going to solve for F2 also. Okay, and you're going to get the F net or the net force because you are asked, find the net force in the object with a charge of negative 4 microcoulomb. All right, so the negative 4 microcoulomb, okay, there are two electrical forces here. F1, which is caused by the 5 microcoulomb charge, and F2, which is caused by the negative 5 microcoulomb charge. Okay, so I will be sharing to you my notepad again. All right, is my notepad there already? I will check. Okay, it's there. All right, so another page. Okay, so we have again our two forces. Do not forget your x and y coordinate plane. Okay, this one here will be your F1. Okay, and this will be your F2. All right, so F2 here forms an angle. Sorry, forms an angle of 45 degrees. All right. So let us first compute for F1. In the previous screen, there is the computation there. Okay, so again, I will be posting the slide for you. All right. So let us first compute for our F1, which is K Q1 Q2 over R squared using our Coulomb's law. So we are going to use the Coulomb's constant again, 9 times 10 to the 9. I will not be putting the units anymore. Okay. Our Q1 will be the 5 microcoulomb. So you have 5 times 10 to the negative 6. So I cannot put the 6 anymore. Okay, dira na lang guys ha. Sorry. Alright. And then Q2 will be 4 times 10 to the negative 6. So take note, I am not putting in the negative sign for the negative 4 microcoulomb because it is in absolute value. Q1, Q2 are in absolute value. Alright. Over the distance between them is 20 centimeters. You should have that in meter. So 0.2 meter squared. Okay, again, guys, never forget to square that one. Okay, so our F1 value is 4.5 newtons. All right. Now let us also compute for F2. F2, the same formula, K, Q1, Q2. All right. So we have 9 times 10 to the 9. Multiply it by our charges. You have 5 microcoulombs, so times 10 to the negative 6 and 4 times 10 to the negative 6. Again, no negative sign for our charges anymore. And the distance between them, it is the hypotenuse that was already computed for you, which is 28 centimeters, and again have that in meters, so you have 0.28 meter. And you square that, never forget the square. So F2 is 2.3 newtons. All right, so we have our values now. F1 is 4.5 newtons, while F2 is, I'll just put that there, 2.3 newtons. Okay, so you are asked for the net force. Here, you cannot add directly F1 and F2. All right, why? Because these are vector quantities. For vector quantities, the direction must be considered. It is magnitude and direction. All right, so we are going to get, or you can use the graphical method. You can also use the component method. So kindly review on that. Vectors. All right. So for this example, I will be using the component method, which will be easier for for me because I don't have to show the graphical method using ruler, protractor, graphing paper. Okay, so let's just use the component method. Okay, so here, since F1, sorry, no, since F1 here, oh, wait, back. Okay, so here, F1 is directly along the x-axis, while F2 is at an angle. Okay, so for component method, our F1, let us draw again. Let's go to another page and draw again. F1 is going here, and F2 is going here at 45 degrees. So let us get the components of the forces. Okay, so F1x, that is directly 4.5 newtons. And F1y is 0 because F1 is directly along the x-axis. Now, F2x will be, the x-axis is here, and it is adjacent to your angle. So you are going to use cosine. Okay, do not forget your SOHCAHTOA. Cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. And this is again our F1x, which is adjacent. Adjacent is near. Okay, and F1y is here. For F1y, if we are going to put that here, it's gonna be opposite from our angle. All right, so F2x will be 2.3 newtons times cosine theta, and our angle is 45 degrees. Okay, and F2y is 2.3 newtons sine theta, and our angle again is 45 degrees. So you have now the values for F2x and F2y, and get the summation for that one. Okay, so for the summation of forces along X, you have 4.5 newtons, and F2X is going to the right. Oh, sorry guys. I made a mistake here. This must be F2X and this must be F2Y. Okay? F2X is going to the right, therefore it is positive. Okay? And our value for F2X is F2X will be get my calculator first. Oh. So, kayo, diri wala kayo san, guys. Okay, cosine 45. And then, ang akong calculator is solar. Times 2.3. So, it is 1.626345597 and so on. So, just add that. Let's just have it. Do not round off your answers, okay? So, just round off at the last part. Okay, so plus 4.5. So we have 6.126 something, etc. Again, do not round off, just round off to the last part. I will just be, okay, dira na lang ko taman. Summation, forces along y for F1y is 0. For F2y, sine 45 times 2.3. It's the same, 1.6 something. Okay, so we have 1.626 something. Okay, now after that, you are going to get the resultant force. Okay, for the resultant force, I'll just use FR. It is equal to the square root of the summation of f of x squared plus the summation of f of y squared. Alright, so just get the square root of 6.126 squared plus 1.626 squared. I will do away with the units again. Just make sure that you are consistent with your units in the first place so that you don't have any problem for that. And our resultant force will be equal to 3.31 newtons. Okay. Now we do not end our computation with this because since this is a vector quantity, we need the direction. Okay, so how are we going to get the direction? Another page. Our direction will just be the inverse tangent of the summation of forces along y over the summation of forces along x. Okay, that is inverse tangent. All right, so inverse tangent. What are the forces? What is the summation of forces along y? What was our answer? 1.626. Okay, and the summation of forces along x, sorry, is 6.126. 6.126, okay? And our angle is 29 degrees. Now, how are we going to determine our direction? Okay, where in the quadrant? Okay, so we can determine that our summation of forces along y is positive and our summation of forces along x is also positive. They are both positive. So it must be in the first quadrant. So if we are going to check again, they are both positive and positive. So in the first quadrant, I will check my answer first, if they are correct. Hey, son. Okay, there you go. 1.626 divided by 6.126 inverse tangent. Oh, why? What happened? Wait, guys. Nakoy sayop, guys. Sorry, sorry. Why? Sine 45 times 2.3 is 1.6. And then cosine is also 1.6. Nakoy sayop, guys, sa way. Oh, there you go. F1x is going to the left, so this will be negative. Sorry, guys, this is negative. And I'll erase this one. Sorry, guys. Alright. Okay. Negative 4.5, 1.6 minus 4.5. So this will be negative 2.9. Okay, so Fy is okay. Negative 2.9 here. Sorry, guys. Mhm. So we have negative 2.9 squared. May gani akong check. Okay. Plus 1.626 squared. And then you extract the square root. 3.31. All right. Okay. So here, this is not 6.126, but this is negative 2.9. Okay, so 1.626 divide 2.9. Okay, and inverse tangent 29 degrees. Okay, so our Fy is positive and our Fx is negative. Okay, so where in the quadrant would that be? Okay, so for positive y and negative x, it is in the second quadrant. So in the second quadrant, if you are going to have your north, south, east, and west, this is your quadrant 1, quadrant 2, 3, and 4. For the second quadrant, you have positive y and negative x. Okay, so you must take note of the directions. All right, so in the second quadrant, that is northwest. So that is your direction for your net force. All right, so I also have here another problem for you to practice. Okay, I will be sharing this screen again. Okay, it's there. Okay, so the solution is also here for you guys. Okay, so I have another example for you to practice, and you also have examples in your modules for you to practice. So that's just it for this morning, or for today, or evening for you, or whatever. All right. Okay, so if you have questions, just kindly message me on Canvas. So take note, we will not be meeting on our scheduled TDOA class. You can watch this recording anytime you want, but you must start working on your module every before Thursday of each week. Okay, so by Thursday, if you are going to meet with our consultation hour, again, you are not required to attend the consultation hour, but I will be there. So if you have questions, if you have confusions or anything with regards to the topic, you can just call me. Okay, I will be there at that time. The Google Meet is on. Just call me, whatever problem you might had with regards to our topic. Okay, so thank you very much for watching. Subscribe to this channel and see you again for our next lecture recording. Bye, guys.